Hello students, in this video we'll see an example of a negative binomial distribution. Let's suppose that a quarterback is picked with 1 with probability 1/20 in each pick of the first round of a 30-person draft. And we'll assume that each pick of this draft is independent. Each pick is independent. Let's find the probability that the number of quarterbacks picked is equal to 3. What we can do is we can note the number of quarterbacks picked is negative binomial. And so for negative binomial random variables, the probability that n is equal to r will be equal to n minus 1 choose r minus 1, p to the r, 1 minus p to the n minus r, where n is the number of trials and p is the probability of success. So for our problem, the probability that the number of quarterbacks chosen is equal to 3 will be, my number of trials is 30, so I'll have a 30 minus 1, and then 3 minus 1. The probability of selecting a quarterback is 1/20 to the power r, in this case is 3. And then 1 minus 1/20 is 19/20 to the n minus r. So I have n equals 30 and r equals 3, so I'll have a 27 over here. So if we simplify this, this will just simplify to 29 over choose 2. And then on top I'll have a 19 to the 27 power. On the bottom I'll have 20 to the 3rd power, 20 to the 27th power, so that'll be 20 to the 3rd power to the 30th power. And that's our probability. We can also note that the expected value of a negative binomial variable, the expected value of a negative binomial random variable, is just going to be the number of successes required over the probability of the success. So in this problem, if we want to find out the total number, so the total number, the number of trials of picks required, the expected number of picks, to get 3 quarterbacks will be r 3 over p, which in this case is 1/20, which will give me a 60. So in a 30-person draft, we know that 3 is less than, for a 30-person draft, we know that if you want to get 3 quarterbacks, you should expect to have at least 60, so we expect to have a little bit less than 3 quarterbacks drafted in a 30-person draft with this probability. Thank you very much.